Let's talk talk about carbon resistor. Uh, these The shape of carbon resistor as shown in the figure. There is a strip of color, colored strip. These colored strip represent the resistance and their percentage accuracy. Now color code. Uh, Different colors have different meaning. For example, if black is mm, black represent B and its digit is 0, multiplier is 10 to the power 0 and tolerance is nothing. Similarly, brown B, digit 1 and 10 to the power 1, multiplier. Red R, digit 2 and 10 to the power 2. Orange O, digit 3, 10 to the power 3, multiplier. Yellow Y, digit 4, multiplier 10 to the power 4. Green uh, G, represented by G, and its digit will be 5 and multiplier will be 10 to the power 5. Blue, letters will be B and digit 6, multiplier will be 10 to the power 6. Violet V, digit 7, 10 to the power 7. Green, digit 8, multiplier 10 to the power 8. And white W, digit 9 and multiplier 10 to the power 9. Tolerance is tolerance for these all colors are 0, but gold have no symbol, okay, and no digit. It is only used for multiplier 10 to the power minus 1. Similarly, silver 10 to the power minus 2, and tolerance will be 5% to 10%. If there is no color means 20% tolerance. To keep in mind, we can use this sayings, that is BB Rai of Great Britain has very good wife wearing gold silver necklace. You should take all capital letters to represent. For example, here in a resistor, which strip what will it represent? So if first strip is represent digit, again second will represent digit, but third strip will represent multiplier, and fourth strip will represent tolerance. If there is no fourth strips, then the tolerance will be 20%. Or note, if fourth strip is absent, then tolerance is 20%. For example, let's calculate the resistance of a resistor. Here it is given, that is red, blue, red and silver, and both sides a pin is drawn, but one pin will be small and another pin will be big, and it is given in a resistor where which pin we have to start seeing the strips. Generally, a smaller pin from a smaller pin we see the color of a strip. For example, here or here it represents for example, here first strip represents red, second blue, third red and fourth silver. Then we have resistance R equals to, for red it is 2 digit, it will represent digit, and blue the 2 6 So blue, if this strip is blue, we have to write its corresponding digit 6, and for red corresponding digit 2 to 2 6. Now third strip will represent multiplier to 10 to the power, because it is red, so red have multiplier 10 to the power 2, so it will be 10 to the power 2. And fourth strip represents tolerance. It is given silver. Silver has tolerance 10%, so we can write 10% ohm. So resistance of this resistor will be this, that is 26 10 to the power 2 plus minus 10%. It represent 10% represent the variation in resistance, that is this may be uh, error in resistance. For example, R equal to 2600 plus minus 2600 into 10 by 100 equal to 2600 plus minus 26. So resistance value will be 2860 ohm to 2340 ohm. Find the resistance of the resistors. For here it is green, yellow and brown. There is no multiplier is tolerance is given. So green represent digit 5, so we have to write 5. And then green and yellow represent digit 4, so 4. Now third represent multiplier brown. Brown has multipliers 10 to the power 1. Now because there is no fourth strip, so tolerance will be 20%, so we have written here 20% ohm. So 540 plus minus 20% ohm, hence the value of R will be this. Again for second, here gray represent 8, digit 8, and green represent digit 5. So we have 8 5 into 10 to tolerance multiplier is gold. So gold has no multiplier, 10 to the power minus 1, so 10 to the power minus 1 multiplier. And this is silver tolerance, so tolerance for silver is 10%. So the resistance value of this resistor will be of this value, that 85 into 10 to the power minus 1 plus 10% ohm, or 8.5 plus minus 10% ohm. That is value lies between of this error. Next, seat of EMF. Seat of EMF. The external source which can pump the electrons to maintain the electronic current in a conducting medium is known as the seat of EMF. Its simple and familiar example is a simple cell. The symbol for cell is given here, seat of EMF for cell. Bigger line represent positive terminal and smaller line represent negative terminal. For a cell it is given, that is it is anode and this is cathode, and this is electrolyte. This is made of metal plate. These are metal plate, and this is a solution, chemical solution. Now EMF of a cell. The EMF of a cell is defined as the work done by the mechanism operating within the cell, which delivers unit positive charge from negative terminal to the positive terminal of the cell at the expenses of chemical energy. It is also defined as the work done per unit charge that the source does in moving charge from its lower potential terminal to its higher potential terminal. That is, EMF equals to E represented by E equals to dW by dQ, or E, and unit is joule per coulomb, or called volt. Second point, for source in open circuit, the potential difference V between the terminals of cell is equal to the electromotive force, that is EMF, and thus in open circuit VA minus VB equals to V equals to E. If it is an open circuit, there is no closed circuit, then this terminal point A and the second terminal point B, and the potential difference between these two terminals will be equal to the EMF of the battery or cell, so it will be V will be equal to E. Thus, EMF is also defined as the potential difference between the terminals of the cell in the open circuit. Under closed circuit condition, the source offers some resistance to the flow of charge. This resistance is called internal resistance. Because of this internal resistance, the potential across the terminals of source is decreased by I into R. Thus, in closed circuit, potential difference across the terminals of the cell VA minus VB equals to V equals to EMF minus I into R, that is E minus IR, because some resistance offers internal material of the cell and that is equal to the I into R. And this is called internal resistance. Here the symbol for cell is shown. This represents that is EMF of cell is E, and if here R is given, small r, then you have to consider that internal resistance of cell is R. And this is the condition of discharging. When current goes from positive terminal, then it is discharging. Next point. Next point, we have charging and discharging of the cell. The first, discharging. The figure for discharging is shown here. This is it is a cell is shown with EMF E and internal resistance R, and it is connected with a resistance R with a circuit, and it has made a closed circuit. And when it is open, it is shown here, that is, this is point A and this is point B. The EMF is E and internal resistance is R, is represented by a small resistor. This is the symbol for internal resistance. In this, current is drawn. Now when we connect it to a external resistance, the current will be start to flow. And in this case, current is drawn from the cell, so VA minus VB, the potential difference between point will be V equals to E minus IR. Hence, potential difference between A and B equals to, it is called terminal voltage, or V equals to E minus IR. This is the case of discharging. Now, in the case of charging, in this case, current is given to the cell. Now, in this case, if we see the current is going toward the positive terminal of the cell, then it is the case of discharging. And now here a external source is added, like a bigger battery is added here, and or anything that supply current to the given battery, and it is called supply current because current is coming from the external source, so it is called supply current. When it is not connected to the external source, then it is represented by this diagram, that is, this is the open circuit case and this is the closed circuit case. Now in this case, VA minus VB equal to V equal to E plus IR. This is the case of E plus IR. Next, short circuit. If the terminals of a source are connected by a conductor of zero resistance, practically negligible resistance, the source is said to be short circuited. The source is said to be short circuited in case V equals to E minus IR. So V, this implies 0, or E equals to E 0 equals to E minus IR, and hence I equals to E by IR, E by R, where E is the EMF. For example, here it is shown without any resistance, it is connected with a wire of negligible resistance. Then it will be called short circuited, because potential difference across terminals across this resistance is, because resistance is 0, potential difference also will be 0 about the resistor, but I will be equal to E by R. Next topic is open circuit. When no current is drawn from the source, it is said to be an open circuit. Here source means cell or battery. When no current is drawn from the source, it is said to be an open circuit. In this case, I equals to 0 because no current is drawn. So from it, V equals to E minus IR. E minus 0 into R equals to E, and in this case V equals to E, that is potential difference between terminal is equal to the EMF of the battery when it is in open circuit case. Calculation of circuit. Calculation of current in the simple circuit. We have formula I, that is current equals to total EMF by total resistance. For example, it is a cell which is connected with a external resistance R, and its cell has internal resistance small r. Now if we want to current flowing in the circuit, so we have to use this formula, total EMF by total resistance equals to E net by R net. For example, in this case, for figure A, in this case I equals to, because net EMF is E, so E will be divided by net resistance is R plus R, because external resistance plus internal resistance will give the net resistance. So in the circuit, current flowing is I equals to E by R plus R. Again in this case, both cell is giving current in the same direction, and the first cell has internal resistance R1 and second cell has internal resistance R2, and EMF is E1 E2, so I will be net EMF E1 plus E2 divided by R plus R1 plus R2. In this case, the cell is connected to the opposite, that is this cell giving current from positive terminal, but here in this cell current is going toward the positive terminal. Now E1 is greater than E2, then we have to write formula, that is in this case this will be negative EMF, we have to write with minus sign. So we have I equals to E1 minus E2, because E1 is greater than E2. So E1 minus E2 by R plus R1 plus R2. Now for example, this is given 3 ohm resistance and a cell is drawn. Here positive terminal is connected with this resistance, and this is the positive and this is, and this 6 volt represent EMF of the cell. So I will be E net by R net equal to 6 by 3 equal to 2 ampere. So in this circuit, 2 ampere of current is flowing. Example, in this case, E net by R net equals to 6 by 4 plus 5, 10 by 5. So equals to 2 ampere. Here this represents EMF or direction of EMF is same direction. That is current is from this EMF cell is also in this direction, and from this cell is also in this direction. This is connected in same direction. So this will add up, and so E net will be 6 plus 4, and here internal resistance of is not given, so we will not use the internal resistance value. Only external resistance is given, so 10 by 5 equals to 2 ampere. Similarly, for this case, I will be in, it is in opposite, and it is because this cell is connected in opposite direction, and this is in the same direction. That is, current is coming from positive terminals, and in this case current is going in the positive terminal, so it will be negative. So I equal to 6 minus 2 by 4 equal to 4 over.